So, a radical function is a function of the form f of x equals nth root of g of x, where g is a non-constant function of x. So we wouldn't count f of x equals the square root of 2 as a radical function because that's just, the graph of that is just a horizontal line, so we would call it a linear function. So you need some kind of variable inside the in the radicand. Okay. Now, of course, it doesn't have to be f of x. It could be we could use a different letter for f and a different letter for x. But this is the form that what we call a radical function is going to be in. Don't confuse this with a rational function. A rational function, remember, is a fraction of polynomials. So this is just very different here, radical function. So here's some examples. Y equals, oh, slow down, buddy. Y equals square root of x squared minus 1 is one example. Because you can write the f of x as y, right? F of x equals the square root of 5x plus 1. Y equals cube root of x. These are all radical functions. Just some examples. Implied domains. Remember implied domains from before. If the domain of a function is not given, we assume it is the set of all real numbers that give outputs that are real numbers. Okay, so your domain is some subset of the real numbers, and when you plug those numbers into the function, you should get outputs that are real numbers. So we want to eliminate the real numbers from the domain. From the domain, we want to eliminate the real numbers that would give us outputs that are not real numbers. That's what we're saying, right? So before I had these restrictions on arguments, way back when, and I just listed them, and so we're just going to add a couple more here to this list. So the first one we had was polynomials, no restrictions on A. A is the argument. That's the radicand, the thing inside the radical sign, the g of x in this case, right? The way it's written here, the g of x here. That's the argument of the radical, also called the radicand, right? In the case of radicals, anyway. So polynomials, there's no restrictions on the argument. If you have b over a, regardless of what b and a are, you have to have a not equal to 0 because we can't divide by 0. And then that's all we had before, but now we've got nth root of a. If n is odd, there's no restrictions on a at all. A can be anything. That is, the nth root part doesn't restrict the a, okay? Nth root of a with n even, then we have the restriction that a is greater than or equal to 0. So the important two here to remember, or the most important two to remember anyway, are b over a can't be 0, and nth root of a, so square root of a, fourth root of a, sixth root of a, eighth root of a, all those even even index radicals, a has to be greater than or equal to 0. So to find the domain, you would take the argument a and set it greater than or equal to 0 and solve for whatever your variable is, usually x. Okay, so note, the restrictions are on a, the argument of the function, which is not necessarily x. So not necessarily the input. For example, f of x equals the fourth root of x minus 2. Should slow this down a little bit here. So for f of x equals a fourth root of x minus 2, the argument, so the index is even, it's 4. So we use this restriction number 4 says a is greater than or equal to 0. So that means x minus 2 is greater than or equal to 0, not x, right? And that means x is greater than or equal to 2. So that's the domain, which could be written in interval notation, right, this way here, right there, right, with a square bracket, 2, comma, infinity, parenthesis, interval notation.